let's dive right into this explainer. We're going to explore one of the most daunting, yet absolutely essential leaps in software development. We're talking about the journey of your code, specifically your AI applications, making that massive jump from a safe, cozy local prototype running on your laptop out into the real, functioning public internet. Honestly, it's a true hero's journey. It's filled with trials, tribulations, and a whole lot of hard-earned lessons along the way.
Right off the bat, let's establish the core conflict here. There's just this stark, massive contrast between local development and a public release. Local development, it's a pristine, localized bubble. Your code, your dependencies, your config files, they all live in an environment you know intimately. Hey, it works on my machine, right? We've all said it. But then there's the public release. It is the Wild West. Your code steps out of that safe bubble and enters a raw, completely unpredictable reality. We're talking different devices, chaotic network drops, varied user permissions, real hackers, and totally different expectations.
So, the crucial question we have to ask ourselves is this: what actually happens when you expose it? A local AI demo can look incredibly impressive when you're the only one testing it. But surviving in the real world? That means facing multiple concurrent users, managing runaway token costs, and defending against real, active security threats. We have to figure out exactly how our project survives this crazy transition.
To do that, here is our roadmap for getting our code to maturity. We'll start by breaking that local bubble, then explore hosting and secrets, locking down users and data, setting up automation, tackling modern AI risks, and finally, we'll look at deployment not just as some chore you do at the end, but as a critical professional skill.
Okay, step 1. Breaking the local bubble and stepping into the real world.
So what does breaking the bubble actually mean in practice? Well, it all comes down to deployment. That's the process of moving an app from a dev environment to a target environment where it's publicly usable, maintainable, and controllable. You see, so many learning projects just fail right at this transition because our local assumptions remain totally unconscious. Maybe a file path only exists on your specific Mac, or maybe an API key is hard-coded into a local file. Deployment violently forces us to make all these silent prerequisites visible. It transforms a mere coding exercise into a real, breathing product that relies on reproducibility.
Moving right along to phase 2, hosting, configuration, and secrets. Basically, giving your code a solid home and some much-needed armor. As your code enters the wild, it needs a solid foundation to run on. You generally have 4 main hosting options here. Static hosting is super fast and robust for simple front ends. Serverless is fantastic for event-driven functions that scale on demand. Containers, they give you incredible OS-level control. And managed cloud platforms reduce your operational burden by handling the messy stuff like databases and authentication. But here is the absolute key takeaway. AI apps usually require at least a server-side component. Why? Because you absolutely cannot put your OpenAI or Anthropic API keys in a browser-based static front end. Doing that is literally like taping your credit card to a park bench. They will be stolen instantly.
Which brings us to the golden rule: keep your secrets off the streets. Never, ever commit local.n files to a public repository. Your code dictates what the app does, but your configuration dictates the environment it runs in. You have to treat your API keys and passwords like the crown jewels. Lock them away in secure secret managers provided by your cloud host, completely isolated from your public code.
All right, section 3, users, data, and rights. It's time to put locks on the doors.
Once the application is live, we have to carefully manage who is actually allowed inside. And we need to make a really critical distinction here. Authentication is about verifying who the person is. Think of logging in with an email or OAuth. But authorization is verifying what this person is allowed to do. Just because someone has the key to the front door of your app doesn't mean they get to walk into the master bedroom and read other users' private chat histories. Security cannot just happen in the front-end interface by hiding a few buttons. It must be rigorously enforced at the back-end database level using rules like row-level security. That guarantees users only access their own data.
Section 4, Automation and Observability. Think of this as your deployment pipeline and your digital security cameras. Look, to prevent total chaos during updates, we need automated pathways. This continuous integration and continuous deployment pipeline, CI/CD, is essentially a tangible, automated checklist. You commit your code, push it to a repo, the server automatically builds it, runs your automated tests, and if everything passes, it deploys. This prevents those manual, oops, I dragged the wrong folder errors. And more importantly, it allows for safe,
immediate rollbacks to a previous version if your new update accidentally breaks something. It completely takes the fear out of updating your app.
But once it's deployed, you actually need to know what's happening. That's where observability comes in, and it goes way beyond simple monitoring. In traditional apps, a crash is super obvious. But in AI projects, a lack of crashes does not mean success. What if your application is technically running fine, but the AI is returning completely empty answers, or taking 30 seconds to reply, or burning through API credits at an insane rate? Without observability, reading your build logs, runtime logs, metrics, and traces, you are flying completely blind. It's the only way to diagnose unknown issues.
Which brings us to Section 5, AI Risks and Security, Facing Modern Web Threats.
Generative AI introduces entirely new, high-stakes trials that our code has to navigate. The OWASP Top 10 for large language models outlines these critical risks perfectly. We've got threats like model denial of service, where heavy, complex usage just exhausts your compute resources. We have supply chain vulnerabilities, simply because modern apps rely on so many external packages, models, and datasets. Defending against this stuff requires a multi-layered strategy. You need rate limits, dependency audits, and extremely strict architectural boundaries.
Let's look closer at the most famous AI risk right now, prompt injection. This is an attempt by a user to manipulate an AI's core instructions using deceptive inputs. The absolutely crucial point here is this: a prompt is never, ever a foolproof security boundary. You can't just tell an AI, hey, don't do bad things, and trust it blindly. Because of this, model outputs must be treated as untrusted data. They should never be executed blindly as code, HTML, or SQL commands on your server. Just don't do it.
And these vulnerabilities? They build into severe real-world consequences fast. That massive number jumping up, that is exactly what happens when you don't secure your application. A single unprotected public endpoint sitting there without user authentication or rate limits can instantly escalate your AI token costs from $0 to thousands of dollars overnight. Because AI costs are usually calculated per token for both input and output, you absolutely must have quotas, rate limits, and cost warnings built right into your deployment architecture.
Furthermore, we aren't just dealing with technical risks anymore. We're dealing with a complex regulatory landscape. Frameworks like the GDPR in Europe and the newly active EU AI Act provide the environment that your code has to operate within. Now, our goal here isn't to debate the merits or politics of these regulations, but to impartially navigate them as engineers. If your AI processes personal data in prompts or chat logs, you must practice data minimization. Only store what is absolutely necessary. And you need to document your data flows to ensure transparency and compliance. It's just part of the job now.
And finally, Section 6, Deployment as a Skill, Achieving Ultimate Maturity. Ultimately, bringing code to the public is not just a final chore you rush through on a Friday afternoon. It's a deeply sought-after professional mindset. Take this quote from the GDPR. Data protection by design and by default. It perfectly encapsulates this mindset. It means that product responsibility, user safety, error handling, and privacy aren't things you just bolt on at the very end. They should be baked into your architecture long before launch day. Deployment is that vital transition from saying I can build something to saying I can responsibly provide something.
So I want to leave you with this final thought. Think about your own local projects, the ones sitting safely on your laptop right now. What is the biggest deployment hurdle stopping your project from going live? Is it configuring to build? Managing those tricky secrets? Setting up the database in auth? Are you fearing the token costs? Or maybe not understanding how to set up logs? Ask yourself what specific trial is keeping your project trapped in that local sandbox, and use the concepts we've explored today to finally push it into the real world. Seriously, the internet is waiting for what you've built.